Audience, welcome back to the Keep It Stupid Simple Labs. Ash is here to give the simplest explanation of the most complex topics. This is the continuation and the last video of this particular playlist. My suggestion for you that you can watch this whole video in a color. Come on, give me the color, white color. Yes, great. So watch this video in 1.5x or watch in 2x, okay? Because sometime I will be talking slowly, okay? So pardon for that and pardon for the background music too. So yeah, let's get into the topic. So let's recap first, okay? You know that we have talked about that client and server response, right? That your phone is a client and your phone, in your phone you can browse in Google, right? In Google Chrome, that facebook.com, and facebook.com, once you search for it, it sends the data to the tower, and then data sent through this tower to the ISP, and through the ISP it sends to the server of Facebook, wherever that server of Facebook exists. It can be in India or outside of India, USA, somewhere, okay? The channel which they use to send this data is fiber optic cable, okay? So fiber optic cable, right? And this is the server, the computer which is on for 24/7. It can be a laptop, but when it comes to Facebook, it will look like this. This is the image of server, okay? This is similar to that. And the phone, the user is client. That's a simpler explanation, okay? So a server is a program computer with one job: to take care of Facebook's data and send it to the client, okay? So your request go to the tower, and the tower sends to your ISP, and then ISP just verifies it and sends through the fiber optic cable to the Facebook server, and then it sends back what? Sends back the HTML, CSS, JavaScript base and other files, right? Through that same path, okay? So we also learned that device does not have a permanent IP address, right? This client and server thing we already learned, right? This request, yeah, the client sends the request, data travels and the response goes, and then it also sends the data back. So we also understand that IP address, okay, that it is temporary, it is not permanent, okay? That IP is just a temporary identification of your internet, okay? So ISP gives you while you are online, okay? And the moment your device goes offline, that IP can be reassigned to someone else. Yes, that particular IP, if this is your phone and you have a particular IP address, once your internet is off, right now I have my own internet here, so once it is off, then that particular IP address can be assigned to someone else, right? Now you might be thinking that, okay, if my same IP is assigned to the other one's device, then maybe if I did a crime, okay, then someone else will be, captured, right? No, that's not how things work. There is a very different kind of setup behind the scene, and you will know about it definitely. Please, please comment if you want to know more about this stuff, okay? Comment what kind of topic you want to know about it in very detailed manner, in very simplest manner, okay? If you really like the kind of explanation I give to you, or the presentation I create, okay, so please do it. So we also learned the evolution of the web, okay? Evolution of the web, where at the starting point it was just web 1.0, right? Web 1.0, where you have very static kind of web pages. Then it turns to the, dynamic, right? The very it's like you can create anything here. Here you can create anything. You have everything: Facebook, Instagram, WhatsApp, everything. You have everything here, and here you can only read. It's like a newspaper, okay. But in semantic, here the future of web, like web 3.0. This is 2.0. This is 1.0. Okay, so in 3.0 you says that there is a thought behind that the future here, and every user has a cryptographic key and full autonomy over their own data and security. Ownership shifts from companies to individuals. That's the part of web 3.0 where you have the ownership of your own data. Then the HTTP. The HTTP, Hypertext Transfer Protocol, it's nothing but a set of rules encoded in your device operating system, in your OS, okay, computer's OS. These rules defines how data is transferred, okay, how the client send request, how the server respond, and how everything flows, okay. So that's how the data transmission rules are written in HTTP. Then we also learned that static website and dynamic website difference, right? That every user sees the same content, that is static website. A funnel page or a simple blog, it's just a copywriting image, maybe a video or one call to action button. Everyone sees the same thing, and static pages are built with one only front end code. Okay, so these are just front end code. And the dynamic websites are every user sees customized live updated content. Okay, these sites rely heavily on backend support, such as your Facebook, your Insta, your YouTube, right? So this is the difference. Then we have the front end development and back end development. Okay, so front end development is what? Front end development, whatever you are seeing here, okay, in your screen, or whatever I search in Google, it is front end, okay, and it is based on the this particular technology, HTML, CSS, JavaScript. If you want to see, then I can go for anything, just Flipkart. I just want to see. Okay, open their tools. Yeah, so show me the code. Yeah, so this is the code, and this is all HTML, CSS, JavaScript, guys. Okay, this website is flipkart.com, and this is all CSS, JavaScript here, okay, inside here. So this is the front end, okay. If I go back and the delving into backend, okay, so the HTML, CSS, JavaScript is compatible to browsers, right? You have to make website in such a way that it is compatible to every single browser and also every single particular device. Some sizes are also different, right? When it comes to backend, it's all about logic, okay. There is a very hardcore logic here, the behind the scene part where you can't see anything, okay, but it is the backbone handling data management and logic, runs algorithm that decide what video shows up, like your chat gpt here. You use chat gpt, right? It shows this kind of uh, thing, right? There is this chat, right? Now the thing is that you search here, but there is a behind the scene process, you don't know about it, but how he thinks, how he give you the response, how he give you suggestions, whatever you ask for. So that is a very core backend, which is written in Python, Ruby, Java, whatever language they are using, MERN stack, mean stack, okay, creating and managing database where SQL and NoSQL based things uses, ensuring data security and efficient data retrieval, implementing APIs for communication with the front end. Okay, so this is the front end which is shown, okay, but the back end part you don't know about it, but it is functional through the front end, okay. So, and handling user authentication and authorization, these are the part of whatever we had learned in part 2, okay. Now we are going towards the main stuff, for the part 3. This is where part 3 starts, guys. Okay, TCP protocol. TCP. Okay, so TCP and UDP both are set of rules that works with HTTP. These are worked with HTTP, TCP, and HTTP plus UDP. So these two work together, right? These two work together. Okay, so there is very slight difference. So let's talk about TCP. TCP is what? Transmission Control Protocol. Transmission control. Sorry for my handwriting. I'm writing with my mouse. Okay. Protocol. Transmission Control Protocol. I should have write it here. So make sure that every single data packet reaches to the receiver. Okay, ensure data is delivered in correct order. Okay, so like it is the perfect example where your chats, like your WhatsApp chat or Instagram chat, you know that every single chat, it is not like if you send, it may be like, for example, I need a space here. Okay, so for example, there is one user whose name is GK, and other user and his name is RK. Okay, so GK sends the data, which is a message, to his phone. Okay, so first message is hi, right? This first message goes to as hi. Then second message he sends hello. Okay, then he sends what? He says how are you, bro? Okay, then what he do is he read this data. Now the message goes on like how are you, bro, right? This is the TCP behind the scene job, where he sends each data in a packet. Okay, like individual packet. Okay, and he makes sure that everything goes one after another. It's not like are you how, bro, bro you are how. No, it will not happen like this. It will go one by one, like how are you, bro. So this is what TCP does. Okay, like your Facebook chat, YouTube videos, Udemy recorded courses, you know, the Udemy or Skillshare, you used to uh, learn so many skills, and these are also the example of TCP protocol. Why? Because you can't afford missing pieces, right? Imagine your friend sends, hey Karan, I love to see your bike again. You made a really nice decision by buying it. But if packet got lost, if that particular data got lost, then you will receive, hey Karan, I love you again. You made a nice decision, right? So that would be a disaster, right? So TCP prevents that by guarantee, right? Like the order delivery happens through this TCP protocol. Okay, so this is the perfect example. You have to just remember that particular chat example and also the online classes example, not live classes. Live classes come under UDP. Okay, which is we are going to talk about the UDP protocol. So what is UDP? UDP is user, okay, I already write it, user datagram protocol, right? So doesn't care if some packets are lost. UDP does not care if a single packet got lost. It does not care. Okay, focuses on speed and real time delivery. It only focuses on real time delivery, real time application like gaming and live broadcast. where swift data delivery is crucial despite potential packet lost. So live classes, live, like India versus Pakistan match, India versus Pakistan match. Your online gaming, your PUBG, right? Your PUBG. Here I already have this example as your live online classes in your Zoom, right? Or your gaming, online gaming. This come under the UDP. UDP is what? User Datagram Protocol. So if your internet slows, you see glitches, right? Whenever your internet goes slows, you see glitches and frame drops, lag, or missing movement. Like you may be watching India Pakistan match, okay, and Virat Kohli hit a six, right? He hit a six. If your net cuts out, you miss that particular shot, okay, because UDP only shows present data in your particular smartphone. This camera is showing the camera, okay, camera is showing the live, right, live match. Now Virat Kohli already hit the shot and it is going beyond the boundary, right? Beyond the boundary. The moment your net get lost, this is the moment where you don't know what happened to this particular ball, right? In this particular match. Now this ball is going there, right? And you already lost the internet. The moment your internet come, it does not start with this point and showing everything what happened to this ball throughout this phase, right? It will directly show you this point, this particular point where the ball is already get out of that ground, right? So this is how UDP works. This is really a relatable example, okay? So TCP is reliable, complete, and UDP fast and real time, okay? So this is the thing which I was teaching you, that TCP and UDP difference. This is the comparison. Like TCP makes sure every piece of data reaches the other side, like sending a full message letter by letter and checking each one arrives. UDP is does check, just throw the data. An example like shouting across a room and hoping the person hears it, okay. TCP is slower because it double check everything. TCP, okay, TCP protocol is slower than UDP. Why? Because it checks everything. UDP is faster because it does not care if something get lost, okay. TCP is used for chats, emails, YouTube videos where missing data would break things. UDP is where used for live games, live streams, video calls, where speed matters more than perfection, okay. The same thing in your PUBG game. You also know this, this is relatable. Whenever you are playing your game PUBG, okay, let's suppose someone is firing at you, okay, your enemy is firing at you, da 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 da, okay, and now you want a cover and you somehow figure out a house, okay, and there is a window, okay, you run you run towards this particular window and you just click the button, okay, you just click the button where you were climbing, okay, but because of the glitch, because of this UDP protocol, your character was here again and he just bang 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 kill, right? You understand what I'm saying? Okay, so this is what happened in TCP and UDP. Okay, so TCP fixes errors and resends missing data. It is not going to send the second thing until and unless the first thing is goes, okay. So and UDP is like, it doesn't fix anything, just keep sending new data. It is just throwing without caring if the data is going or not, but it is going to care. It has a very simple format, like the sync and the sync acknowledge, ACK, right? So this kind of thing works, but I'm going to talk about it in a very deep manner when we are going to talk about in a networking session. You can comment, guys. You can comment if you want to get very deep, thorough understanding of how TCP works how UDP works. Okay, I will give a very detailed video. This is just a description. Okay, so yeah, this is the series conclusion. This is where we just end this whole series. But still, there are some points. Don't go back, guys. HTTP and proxy is here. I want to tell you about it. Mm, we already talk about everything, right? This everything is done. So final video of the internet. Yeah. So yeah, not not done yet. Let's go towards the sideboard. Yeah. So we are going to learn the HTTPS. Okay. Yeah, I have the formal way. Yeah. So HTTPS. What is HTTPS? HTTPS means the hypertext transfer protocol, right? But it is secure. It is secure. So it's secure version of HTTP. The protocol we already learned that defines how data moves between your browser, means your client, to the server, right? You already know about this particular stuff, right? So the S at the end is the game changer. It means secure, okay, powered by encryption. Here the encryption part came. So why HTTPS was made originally? So the internet ran on HTTP only. Like at the very starting point, it was just HTTP. Data you sent, like password, credit card numbers, private messages, was plain text, right? It was going on as a plain text, txt. Your password, your credit card or your debit card details were in the internet going through this HTTP previously. Okay, so anyone in the middle, like hackers or Wi-Fi snoopers, even ISPs, could read or tamper with it. Yeah, so they can hijack this data easily. So HTTPS was created to protect users by encrypting the data, so outsiders can't read it. Okay, like this particular data is encrypted in a particular format. It is broke down in certain way and had a particular key. So like authenticating the website, so you know you are really talking to facebook.com, not a fake copy. Okay, like maintaining integrity, so data isn't altered in transition. Okay, so analogy, like think of HTTP like sending a postcard. Okay, you are sending a postcard, you are the particular person, okay, who is sending the postcard. This is the postcard. Who handles it? The postman. Okay, so the postman is the one who is actually sending it, right? The sorting office, even a nosy neighbor. Okay, like this authentication of this particular thing, this particular postcard to the particular postman, and that postman is sending that particular postcard to that particular person you want this postcard to be given. This is a proper data transmission which should be happen in a must encrypted manner, right? That's why you cover it, right? You made a cover, you put so many tapes and so many layers, so then postman can't see what exists in this postcard, right? So this is the actual way you can understand what is HTTPS. Okay, so how HTTPS works, like when you visit a site with HTTPS, your browser and the server perform a handshake. Okay, now I'm going to teach you a handshake, a very detailed handshake. So your browser and the server performs a handshake. This is your browser, he is going to give the hand, and this is the, oh sorry, this is the server, and he is also going to shake the hand. So this handshake will happen, which is going to be the process of encryption in the HTTPS. Okay, so they agree on a secret key For that moment, all communication is encrypted. Even if someone interrupts it, all they see is a gibberish. Like, I'm giving you an example. That particular browser will give the, this is just an example, okay? So for example, this is a Google Chrome, okay, and this is particular server of whatever particular website. So it is a server like a computer, okay, which is on 24/7, right? So what he do is, at first he will send first key, okay. He says that let's make the key as GK, okay. Then computer will say that no, don't, I'm not going to agree with GK, let's pick AB, okay. AB is simple, so pick AB. Then what happen is that the Chrome browser will say that okay, you are not agreeing with GK, and yeah, you are not agreeing with AB, no worries, let's pick the middle path, okay. Let's settle with GKAB, okay. GKAB. So GKAB, one part of browser, one part of AB. Only browser know the first part, and only the server knows the last part. And this is how the data used to get encrypted. Yeah, like for example, I'm just giving an example, that's not how it works, but maybe you are sending the message hi, right? So this message is going toward the server, right? Hi message. Now this hi will come up with the GK lock, okay. Then server do what? He will give the encryption of particular hi message as AB, okay. Now it will go through the path, and within this path it will become GKAB, okay. And now it will goes again, and now you can send hello, okay. And that same process happen again and again, while GKAB will become a very, the common key to actually decrypt this particular message. So this is the proper way. It is not the true thing, but it is the proper way to understand like how this thing works behind the scene. So this is what the HTTPS means, like, and what is it used for? The security, protecting the your sensitive data, okay, your sensitive data, your login details, your payment info, personal information. So and it is also important for trust. User feels safe when they see the padlock icon in the browser, okay. So Google ranks HTTPS signs higher, okay. So yeah, most of the time you will see the websites in within the HTTPS in this is not the Chrome. Why it is not showing the HTTPS site? Yes, but it is secured, right? This is the connection which is means HTTPS. So so what is the, I already told you the relatable example. I already have so many examples, but I think this is not going to be worth it. Yeah, this is one example that imagine if your private DM were visible to anyone on the network, okay. HTTPS prevents it, like banking. ICC, HDFC, SBI, all banking portals use HTTPS with EV certificates. Without it, phishing sites could easily trick you. Like public Wi-Fi at airport or cafes, hacker often run man in the middle attacks. Man in the middle attacks. Do you know about it? Man in the middle attack, right? Like this particular mobile in WhatsApp sending the data to someone else WhatsApp, okay. And hacker with his computer, what he is doing is he will get one copy of your message, right? He will get one copy of your message. So you send the proposal to your girlfriend, your hacker also know that you send the particular proposal to one particular person. What particular person? Whom? Okay. So this is the man in the middle attack. So yeah, so that's the thing, and I have already talked about this, yeah. So let's go on to one more very important topic, which is proxy. Yeah, proxy. You will love it, proxy and proxy versus VPN. So what is proxy? Guys, what is proxy? So proxy server is like a middleman between you and the internet. Okay, when you request a website, whenever you request a website, it can be like, maybe you are searching for a banned website in India. Maybe you are in India and there is a particular website which is banned. Okay, when which you open in your night, right? So that can be grok. Okay, grok.com. So you are searching for grok.com at night. Okay, and this particular site is banned here. You can't access this particular website in your phone or laptop. Now the proxy then forwards this particular request, and this, he sends this data to someone else's computer. Okay, someone else's computer. So like this request goes on to another computer, then this goes on to another computer, and this way it goes on to so many different computers, to the point that it goes beyond India and it reaches to maybe Russia, right? Russia russia So now you have access through this time you are Indian, this time you are Indian, this time you are Indian, but with the proxy you right now reach to Russia. Okay, and now you are accessing this particular site grok.com from Russia's computer. Russia's, okay, so Russia's browser, specifically browser. So Google Chrome. Okay, and so in Russia's Google Chrome the grok is available. Okay, the grok is available. So you search through his particular browser what the grok.com, and through this you can easily access it in your particular browser. This is what is called proxy. Okay, this is what a simple example of proxy, and this is how it is work. Okay, so instead of asking directly, you whisper your question to a friend. Okay, your friend asks, the teacher gets the answer and whispers it back to you. That's what a proxy does. It speaks on your behalf. Why proxies were made? To hide your identity, to control access. To control access. School offices use proxies to block or filter sites. Yes, it is also helpful for that too. To cache content, like store copies of frequent use data to make browsing faster. It is also helpful for that. And types of proxies, there are types of proxies. I'm just going to give you a very simple theory around it. Proxies type is just like reverse proxy. Another one is transparent proxy. Okay, transparent proxy. Yeah, and these are the two I know about it. So like a reverse proxy is like sits in front of server, not user, protects servers and balances traffic, like your Cloudflare protecting website from attacks. Okay, and the transparent one is like you don't even know it's there. It's like your public Wi-Fi at airport. Okay, so these are the two types of proxy. Yeah, and what is it about VPN or VPN? So the full form, right? Virtual private network. Virtual private network. This is the full form of VPN. So it creates a secure encrypted tunnel between your device and the internet. It creates a particular encrypted tunnel between your device and your internet. Okay, so the world. Okay, this is the internet, you can ask. Okay, so all your traffic passes through this tunnel, hiding it from hackers, ISP, and even governments. Okay, so this is the VPN tunnel. Okay, and you can send the data whatever site you want, whatever site request you want, like grok.com. Okay, grok. so you use VPN through it. Now the VPN, what he does, like with a proxy you ask a friend to deliver it, right? But the letter is still readable. Okay, with proxy you can still read the request. With a VPN you put the letter inside a locked armored box, so even if someone intercept it, they can't read it without the key. Okay, so proxy is like a messenger, but VPN is like a armored tunnel. It is very strong tunnel. Okay, so why VPNs were made? To secure data on unsafe networks, to bypass censorship, this is what I'm talking about, to protect privacy, hide browsing from ISPs or governments, to mask location, your location. You know, the in particular hacking related videos or movies, what happens is that whenever a hacker want to found another hacker, they show this particular screen in their computer, that there is a map, right? So once they show one point, okay, the moment they go zoom, like they zoom out to that particular location, that particular location bounces to another location, right? Then bounces to another location, then bounces to another location, bounces to another location. This is what VPN do. Okay, like it hides your particular location. So what are the types of VPNs? Types of VPNs is just like site to site VPN, site to site VPN, and client client server VPN, client to server VPN. These are two types of VPN. Okay, so the real example I already showed you, like you know, the school blocking gaming sites, so you can achieve it, and also anime sites, right? There are so many anime sites, you can access it through the VPN. So this is how, there are so many examples, you already know about it. Maybe you have already using it. So this is the real thing, and this is how we wrap up. Okay, so both proxy and VPN act as middle layer between you and the internet, but they serve different purposes. You know, the proxy is like a mask and filter, and VPN is like secure and encrypted. And mostly proxies are used under the browser, and VPNs can be implemented in directly into your devices. Okay, this is also a very important thing to notice. Okay, so yeah, this is the stuff which I was thinking about, and this is where we ends the series, guys, and this is where I have to go. And yes, one thing I want to tell you, that there is a particular series I'm working on. First series is that Bootcamp Zero. Okay, you can watch that Bootcamp Zero. And also there is also one more series I am working on, which is web dev web dev series. Okay, so please follow these two series. Okay, and comment if you want a certain kind of you know, description, you know, like detailed video around any topic related to technology, related to science, related to anything. Mostly I was inclined towards the tech. Okay, so yeah, with the bonus video, we are officially closing the internet series. This series is designed to give you the fundamental and the most important concept of the internet. Once you have this foundation, you will be ready for the advanced stuff, actually building things, creating products, and understanding the internet powers. Okay, and yeah, we will go from the market research to design to development and everything. And yeah, this is it. Let's change the dynamics of the product creation, guys. Let's change it. So goodbye, keep it simple, build it bold.